All right, welcome to lesson 83. This is figuring out probability of dependent events, and I'll explain to you what that means. Jokes for today. My friend David lost his ID. Now I just call him Dav. Also, why was the king only a foot tall? Because he was a ruler. And lastly, why was the math student always so sad and grumpy? Because they always were working on problems. All right, enough with the lameness. Moving to today's lesson. Okay, so we talked about probability before. If you flip a coin, what is the probability that it will land on heads? Well, there's two sides to a coin, and there's only one heads. So it would be 50%, half of it. So you have two separate things today. We often talk about independent probability, and today we're going to talk about dependence. I'll tell you what the difference is here. So, for example, I'm going to give you an independent probability problem here, and independent means that it's by itself. You are still dependent on your parents. These things are independent. They don't rely on anything. In other words, flipping a coin does not rely on how you roll a dice. So if you flip a coin and you roll a dice, if the dice lands on 6, that doesn't mean that the coin's going to land on heads or tails. It doesn't mean that. It doesn't have any relation. So independent here is flipping a coin. So if I flip a coin, it could land on heads or tails. If I roll a dice, it could land on any numbers 1 through 6. And the way we figure out the probability, so if I wanted to roll a heads and let's say a 5, how would you figure that out? Well, what's the probability of landing on heads? It's 50% or 1/2. And what is the probability of landing on a 5? It is out of the dice, it's 1 out of the 6 options. So what's the probability that it's going to land on heads and number 5 on the dice? Well, the way you figure out independent probability is you just multiply those things together, right? This is the probability of A, and this is the probability of B. The way you figure that out is just do A times B, and that will figure out your probability for this event. So 1/2 times 1/6 is 1/12. So you have a 1/12 probability that it'll happen. So that's independent. It's completely separate. Now, here you have, I'll give you an example of a dependent, a probability that the two things are dependent on each other. So if I have a bag of marbles here, and I have 3 white ones and 3 black ones in here, that's what these are in there. And if I reach in there and I'm going to try and figure out what's the probability that I pull a white and a black one out, well, you might look at that and say, well, that's going to be 50% that I pull 1 white and 1 black. That depends. It's dependent on something. So let's just say the first pull. I have a list here of all the things we could pull for the first pull. So if I reach in and pull out, I can pull a black one. I can pull 3 black ones. I can pull 3 whites. Now, here's a question for you. And that is, if I reach in there again, there is a slight problem here. Because if I reach in there and I pull, so the first pull, the chance that I get let's just say a black one on the first one. A black pull on the first one. What's the chance? Well, there's 3 blacks and 3 whites here. So it's 50% chance that I pull a black one on the first. So first black would be 1/2. Now, if I pull that one out and then don't put it back in, that means all of a sudden something's different here. There's only 5 marbles in. So what's the chance that it's no longer 50% because there's 5 marbles? What's the chance that I pull a white one out for the second pull if I don't put the first marble back in? Well, there's 5 marbles and there's 3 white. So the probability would be 3/5. So no longer is it, depends what you do on the first pool will depend what happens on the second pool. So you have a 50% chance on the first pool, and there's all these marbles in, to pull a black one out. Once you have the black one out, you have a 3/5 chance to pull a white one out. So that means the way you figure out the probability is 1/2 times 3/5 is 3/10. So the probability that you will pull out a black one and then pull out a white one is 3 out of 10. Now that can change very quickly. So let's say I wanted a black one on the second pool. So if on the first pool, 3 out of 6, 1/2 are black. So I have that chance. I have 50%, 1/2 chance to pull a black one. If I take that black one away, and then I want another black one, the difference is now there's 2 out of the 5 that are another black. So the probability of me pulling 2 black ones out is now 2/10. So that changes very drastically, very quickly. It all depends what you pull on the first one, what happens to the second one. So you have to adjust it there. It's not 1/2 times 1/2. Now, what can happen is, so if you say, if I pull a black one on the first time, which would be 1/2, so if I pull it out, it's gone, and I put it back in, what's the chance that I pull another black one? Well, if you put it back in, it's still the same. So there you have a 50% chance, or 1/2, of pulling 2 blacks. It depends whether or not you put that marble in again after you take it out. So that's where the dependent thing comes in. It depends what you do on the first time will affect the second one. So that's what we're talking about, the dependent thing. So that's that. It pretty much, the first pool, what you get, what happens on the first pool, that will determine what can happen from there. And the way you would actually write this out, I'm not going to waste time, because so if I pull a black one out on the first time, that means it could be black, black, white, white, white. So if you would do that to all of them except down here on the white, you pull a white one out, you would have 3 blacks and 2 whites. And then if you would go through and circle all the ones, so there's 1, 2, so there's 2 out of 5 that if you would go through, you would figure out that, see, I'm doing a black and whatever it is, whatever you're trying to figure out, you would be able to figure out your percentage, but that takes a while. This is much faster. Take the probability of the first pool, probability of the second pool, and that will give you your probability. Okay, let's just move to example 1 here. Let me write it up on the board. All right, example 1. So there's 2 8th graders and 1 7th grader, and there's going to be a trip. I don't know how this all works out, but there's a trip, and only 2 of them can go. Obviously, go 8th grade. We want both 8th graders to go. What's the probability that both 8th graders are going to go? Because there is 1 7th grader in the mix there. How do we figure it out? Well, so let's say we throw their names in a hat, and we're going to pull out whether, and then out of the hat and see who goes. So if we reach in there, there's going to be 2 students, and after you pull a name out, you're not going to put that name back in. You're going to pull it out and leave it out. So on the first pull out of the hat, this is what's going to happen. You're either going to get an 8th grader, an 8th grader, or a 7th grader. And then on the second pool, you're going to then, there's how many names left? So if you have a hat, and there's 8, 8, and 7. So if you pull one of the 8th graders out, that means you're going to have an 8 and a 7 left. So we'll just draw it like this, 8 and 7. This one, same thing, 8 and 7. And obviously, if you pull the 7th grader out, that means there's going to be 2 8th graders. But by the time you figured out that you pulled a 7th grader out the first time, then you know that there's no chance that there's going to be 2 8th graders going. So if you look here, the first pool needs to be an 8th grader if you want 2 8th graders to go. So how many possibilities? There's 1, 2, and 3 possibilities. 2 of them are 8th graders. So on the first pool, I'll write this down here. First pool, you have a probability of 2/3 that it'll be an 8th grader. On the second pool, so we'll just put a multiply sign there because there's going to be a probability for the second one. On the second pool, what is the probability that you're going to pool an 8th grader's name? Well, if you go down through how many possibilities there, 1, 2, 3, 4, 5, 6 possibilities here. So how many out of the 6 are an 8th grader? Well, 1, 2, 3, 4. So 4 out of the 6, which is also 2/3, is your possibility for there. Now you might think, oh, okay, the answer is 2/3 because obviously 2/3 must be 2/3 chance. That would make sense. Not exactly, because you have to multiply them together. So the probability of the first draw is 2/3 of them would be 8th graders. The probability of the second draw, 2/3 of them would be 8th graders. So you multiply those two together, you get 4/9. And that is your probability there. Now, if you would actually change that to, you know what? I think I did something wrong here. Hang on a second, let me fix this. Okay, bummer. Can't just delete that video, but this is actually what happens here. So the first chance is these 2 8th graders. So then you have to ask yourself, what out of the positives? So you can actually just forget about this one down here, because this is already out of the picture. That's not going to help us out. Then you have to look at this and figure out, so which one of these is benefiting me? Which one is achieving the result that I have? So here, these are okay in the first pool. Then the second pool, these are your options here. And what is the chance that you're going to get another 8th grader? Well, if you look at it, there's 1, 2, 3, 4 options. 2 of them are 8th graders. So 2 out of the 4, or 1/2, is going to be the probability that if the first one's correct, the second one can be correct. It's a 1/2% or 1/2 probability. So 2/3 times 1/2 gives you 2/6, which is 1/3 simplified there. So you have a 1/3 possibility to figure out to get 2 8th graders on this trip. So you have a 1/3, 33% chance to make that happen. Kind of unlikely, but there's a chance that it could happen. Okay, example 2 then, you have a problem here, kind of like the one that we did. And they're asking, there's 5 marbles in this bag. There's 3 blue ones and 2 white ones. They're wondering, what's the chance that you're going to pull 2 marbles out? What's the probability or the chance that you will pick 2? And on the first attempt, A, you're going to put it back. So it says are selected A with replacement. So if you replace the first one that you pull out, what's the chance? So you ask yourself a question now. So the probability of A and the probability of B. What's the probability of A that you will pull out a blue one? Out of this, 3 blue out of 5. You pull that out like that, and then it says you with replacement, so you put it back in. So the probability of B, it doesn't change at all. They're completely dependent. You reach in, you pull it out, look at it, you put it back in, and then you reach in again and pull it out. They're 2 separate events. The first one will not affect the second one, so they're independent. So then you put this down, 3/5, they're both the same for that. So the way you would figure that out is then what's the probability of 2 blue when you put it back? We get 9/25, which is 36% chance there. So that's if you put it back. Now, if you don't put it back, so if on the first pull you pull out a blue one, so that gives you, again, that was a 3/5 chance for the first one. Then the second one, what's the chance that you'll pull a blue one out if the first time you pull a blue one out and don't put it back? It's dependent on the first one. So here you have a 1/2 chance in the second one. See, your fractions change because the first one changes it. It's dependent. So then there you have 3/10, which is a 30% chance. It's actually, you have a slightly better chance putting it back than you do not putting it back. But here's your difference. This is 36%. This is 30%. All right, let's go ahead and move on to the practice set here. All right, so let's go ahead and go through these here. This is actually super fun because you can start figuring out, like if your friends say, oh, I bet you can't guess this or that. And you can actually figure out the probability of something that you are right. And if you're competitive at all, you can be like, oh man, I had a 50% chance and I got it wrong. Or I had a 33% chance and I got it right, whatever it is. But you can start figuring that out. So the first practice set, A, it's asking you a question. It says, if the spinner is spun twice, are the events independent or dependent? You're supposed to justify your answer. In other words, explain it. So if you spin the spinner here, you spin that. What is, let's just pick a number. Let's say it lands on 1 like it has there. So if you spin it and it lands on 1, is the second spin affected by what you spun on the first one? The answer is no. Because if you spin and it lands on 1 like it is, it's not like poof, that number 1 disappears and then you only have 2, 3, and 4 left. It's kind of like if you roll a dice and you lands on 1, the 1 gets like disappears, it blows out of here. They're independent because the second spin is not affected by what you get on the first spin. Problem B here, this is another fun one here. There's 4 different cards. They're all face down. I'm pretending that they're see-through just for sake of illustration here. And they're lettered A, B, C, and D. And they want you to figure out, there's 4 things that they have here that they want you to figure out. So the one stipulation they have here is when it is turned around, it stays letter side up. Like you can see it then, so you can't flip it around again. So the problem for number of the first one, it says turning over the A card first. What is the chance of turning over the A card? There's 4 cards. What is the chance of turning over the A card? Well, it's 1 out of 4. So what's the probability? 1/4. You have a 1/4 probability of doing that. So that's the first part. The second part takes it a step further. If you turn over A, what's the chance of turning over A? It is a 1/4 chance of turning over A. So now it's turned up, and that means, let me move to the other side here. That means they want to know out of the 3 remaining, what's the chance that you turn over the B card? Well, it's 1, 2, 3 cards. It's 1 of them. So it'd be, the second would be 1/3. So you multiply these 2 together to figure out the probability. 1/12. That's your chance. So for the first, just turning over red one, or letter A is 1/4. For turning over A and then B, you have 1/12 of a chance to figure that out. Number 3 there, or third thing, turning over A, B, and then C. So same thing here. If you turn over A, it's 1/4. If you turn over A, then what's the chance of you turning over B? It's 1/3, just like we figured out above here. Except now, what's the chance of you turning over C if you turn over both of these? Well, that's left is C and D, so you have a 1/2 chance at the end. And that, multiply those together, circle all the way. 1/4 times 1/3 is 1/12, times 1/2 is 1/24. 1/24 is, obviously your chance of getting it right is getting smaller and smaller, as would be expected. And then the last option, turning over A, B, C, and D. Well, you can ask yourself a question before you do this. If you get the first 3 right, what's the chance that you're going to get the last one right? 100%, or 1. So it doesn't even change your answer, because if you flip A card around, it's a 1/4 chance. The B card then is 1/3 chance. The C card is 1/2 a chance. And if you have all three of these turnover, what's the chance that you'll turn over D? 100% or 1. So this is what your answer is. 1/4 times 1/3, 1/12. Times 1/2, 1/24. 1/24 times 1 is 1/24. So in other words, if you get the first three right, you will get, say, you have the, I mean, it's going to be that you turn over D for the last one. So for those four things, it's 1/4 chance, 1/12, 1/24, and 1/24. Moving on to C, the same cards, A, B, C, and D. They're face down on a table. She turns over one card, turns over one of them, and finds that it is A. So in your directions, she already turned over A. What if she turns over the remaining cards one at a time? What is the probability that she turns them over in alphabetical order? So A, B, C, and D. Well, you could start figuring it out, or you could be like, well, is this at all similar to any of these? And it's not quite, because of one fact. She turned over A, and then they're wondering about the probability. So A is turned over. So we can actually forget about that one, because A is taken care of. It's asking what's the chance that she turns over the rest of the cards in alphabetical order. Well, what's next? B. What's the chance that she'll turn over B here? Is a 1/3 chance, right? So then if you get that, what's the chance that she turns over C? It's 1/2. And if she turned over B and C, what's the chance that she'll turn D? It's 1. So 1/3 times 1/2 times 1 is equal to 1/6. So it's much better if you take the first one out. You have a 1/6 chance compared to 1/24 getting out alphabetical order. Okay, hopefully this is making sense. I feel like I'm, making stuff up kind of, but hopefully you can figure out what's going on here. Dependent things, you just multiply the probabilities together. For D here, you have a bag of 6 marbles, 3 reds, 2 whites, and 1 blue, I think it is. Yes. And you're pulling out 3 marbles, not putting any back in. And what's the probability of drawing red, then white, then blue? Let's go ahead and figure that out. So a red, a white, and a blue. So what's the chance of pulling out a red one on the first pull? 3 reds, 3 non-reds. So it's 3 out of 6 or 1/2. There's a 1/2 chance. So we pull out a red one. Then what's the chance that we pull out a white one? Well, it's 2 whites out of 5 marbles in there, so it's 2/5. So we pulled out a white, and what's the chance of them pulling a blue? 1 out of 4 marbles, so it's 1/4. So that probability of pulling a red, then a white, then a blue is 1/2 times 2/5, which is 2/10 times 1/4, which is 2/40. That reduces down to 1/20. That is your probability of pulling a red one, a white one, and a blue one. Now, if you go back to the first sentence in D, it says, recall that the probabilities of an event and its complement. In other words, the complement is the probability, the first thing, the probability of an event is what's the chance that it'll happen. And the complement is everything else. So this plus everything else should equal 1, right? That makes sense. So then the second question that they ask in there, it says, what's the probability of not drawing red, then white, then blue? Well, if this reduced down to 1/20, then that means there's 19 out of 20 possible solutions for not turning over a red and white and blue. Because you add these together, it equals 1. That's all it's asking there. Figure out the probability of the first thing, and then what's the chance of it not happening? This right here. And letter E has. So you have Gary, and he has some socks. He woke up and he's stumbling through the darkness and he's looking for socks. And he has 2 black ones and 4 blue ones. He reaches into his sock drawer, and what's the chance that he pulls out both black ones? Well, what's the chance for the first pull? He reaches in, grabs the sock, it's black. That means out of this, he had a 2 out of 6. So the first pool for black was 1/3 is what it reduces down to. 2/6 or 1/3. Now, he pulled out that color for the first one. That means he has one out. Now he has 1 out of 5 remaining that are black. So that's 1/5. So the chance of him pulling out both black socks is 1/15. That's his probability for that one. So to summarize, just take the two things, and if the second result is dependent on the first one, do the first one, and then figure out the second one, multiply the probabilities together, and that will be your answer for the total probability.